We'll start with the chemistry lessons. Yeah. Structure of matter. The things in the environment can be classified as matter and energy. Matter and energy. Those that occupy the space and have a mass are known as matter, solid, liquid, or gas. The classification of matter according to the physical nature and chemical composition is summarized in the following chart. Matter. According to physical states, there are three physical states: solid, liquid, and gas. Solid, the particles are close by due to strong interactions. Liquids, lesser interactions than that. Gases, even less. Gas particles, they show random motion. According to the chemical composition, there are pure substances and mixtures. Pure substances can either be elements or compounds. Elements means the simple building blocks: iron, oxygen, copper, nitrogen, like elements. Compounds, they contain more than one element: water, H2O, carbon dioxide, CO2. Then there are mixtures of matter, homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures, salt solution, sugar solution, means their composition everywhere in the solution is the same. Their composition everywhere is the same. Same particle distribution. Heterogeneous mixtures, they are not uniformly distributed. Lime and water, rice and sand. Now if you take soil solution, soil particles will dense down and upper layer will be clearer than that. So it is a heterogeneous mixture. Here in this lesson, we want to discuss specially about elements or atoms. Atoms are the building units of matter. Atoms are composed of subatomic particles. You know the subatomic particles: protons, electrons, and neutrons. So atoms are the building blocks of matter. Whether it is a solid or a liquid or a gas, atoms are the building blocks. And there are three subatomic particles: protons, electrons, and neutrons. Electrons are negatively charged. Protons are positively charged. Neutrons are neutral. So now we know there are three subatomic particles. Then the scientists wanted to know, they wanted to introduce how these subatomic particles are arranged in an atom. So different scientists put forward different models. Ernest Rutherford, he brought the model. He brought a nuclear model. His model was nuclear model. Nuclear model. Nuclear model means now it is like a small area. In the middle is the nucleus or the center of the atom. if the atom is like a football ground, it's a huge area, the nucleus is a very small volume. It is like the football. The nucleus is in a very small area. The whole other area is the atom. So that is the nuclear model. So the center is very small. Protons and neutrons are accumulated in the nucleus. It's like the football. Protons and neutrons are accumulated in the center. Protons are positively charged, neutrons are neutral. The nucleus is positively charged because protons are positively charged, therefore the nucleus is positively charged. Electrons revolve around the nucleus. So electrons are distributed all over. It is like the football ground. And the center is like the football. It has protons and neutrons. So the number of electrons in the atom is equal to the number of protons. So nuclear models suggest these ideas. The number of electrons are equal to the number of protons. Number of positive charges, protons, are equal to the number of negative charges, electrons. Right? So due to that reason, the number of protons and number of electrons are equal. The number of positive charges are equal to the number of positive charges. Therefore, the atom is neutral. Therefore, the atom is neutral. This is like the football ground. This is the nucleus. So the nucleus contains protons and neutrons. All around there are electrons. So the number of electrons are equal to the number of protons. Therefore, number of positive charges are equal to the number of negative charges. Therefore, the atom is neutral. Then the second model, the planetary model. The planetary model of the atom. The planetary model of the atom was by, again, Ernest Rutherford. Ernest Rutherford. He himself understood the weaknesses of the nuclear model and he brought the planetary model of the atom. The planetary model of the atom was by Ernest Rutherford. Electrons move around the nucleus, in which the positive charge of the atom is concentrated. I told you, protons are in the middle. So, electrons move around the nucleus. It is like the solar system. So, electrons move around the nucleus in different pathways or elliptical pathways. Electrons are attracted by the positive charges of the nucleus. Of course, there is an attraction between positive charges and negative charges. But these electrons do not fall on the nucleus. That is because electrons revolve very fast around the nucleus. So the planetary model suggested how electrons revolve around the nucleus. The previous model, the nuclear model, did not suggest that. Then the third model, Niels Bohr. Niels Bohr, based on this planetary model, he elaborated the Rutherford's planetary model. He further stated that the electrons move in definite paths or shells or energy levels around the positively charged nucleus. These energy levels or shells in the electrons revolve around the nucleus, and he gave numbers to these levels or shells where the electrons are moving as 1, 2, 3, 4 levels or KLMN shells or energy levels. The shells are also known as energy levels. These energy levels have specific energy. When moving away from the nucleus, energy increases. When moving away from the nucleus, energy increases. The difference between the energy levels decreases. The gap decreases, but the energy increases. Energy increases from 1, 2, 3, 4, but the gap between 1, 2, 2, 3 decrease. In an atom, there is a maximum number of electrons which can be filled to any energy level. It gives the total number of electrons in the energy levels. So there is a specified energy for each energy level, and there is a number of electrons that can be filled. If you consider the first energy level or the K level, maximum number is 2. Second energy level, L, 8. Third or M, 18. Fourth or N, 32. Then this is the Bohr's model, Niels Bohr model. Look at the energy levels, look at the gaps. The gap decreases and energy increases. Energy increases from K to N, but the gap decreases. Then we should know the atomic number and the mass number, which are very important. Two numbers when it comes to atoms or calculations or properties. The atomic number is the number of protons in the atom. So atomic number is equal to the number of protons. If an atom is given, if you ask the atomic number, that is the number of protons. It is a unique characteristic for that element, and the atomic number is given the symbol Z. An atomic number is indicated as Z number. It is symbolized by Z. If you consider the sodium atom, the atomic number is 11, means the number of protons are also 11. Now in a chemical reaction, either electrons are removed or electrons are accepted. But the protons are in the nucleus, so the number of protons do not change during a chemical reaction. Therefore, the atomic number also does not change during a chemical reaction. Then the mass number. Mass number is indicated by capital A. The mass number is also a characteristic of a particular atom with regard to subatomic particles. Then we should know what is mass number. Mass number is the sum of protons and neutrons in the nucleus. You know, protons and neutrons are together in an atom. So the sum of protons and neutrons in an atom is the mass number. Now, if you are given the atomic number, you know the number of protons. Then, if you know the number of neutrons, you can calculate the mass number. So we can write an equation for mass number. That is, A equals number of protons plus number of neutrons. Number of protons is equal to atomic number Z plus neutrons. So the mass number is number of protons plus neutrons. Number of protons is equal to atomic number. Therefore, mass number equals atomic number plus neutrons. Now, if you consider sodium, now when we write the atomic number and mass number, we write like this. X is a certain atom. A above, Z down. It means the mass number A above, atomic number down. So A is mass number, Z is atomic number. Now here, if you are given these details, you should be able to calculate the number of protons, number of electrons, and number of neutrons. Now, Na equals Na 23 11. Now you know what is 11. 11 is Z. That is the atomic number. So, if you know the atomic number, that is equal to the number of protons. So, number of protons are 11. You know atoms are neutral. So, number of protons are equal to number of electrons. Therefore, 11 is also the number of electrons. Then you should be able to calculate the mass number also. Now here the mass number is given, it is 23. Right? So if you want to calculate the number of neutrons, how to do that? You can use this equation. It is like this. Now, mass number is A equals number of protons. Protons are 11 because that is equal to the atomic number. Then the number of neutrons you don't know. A you know. Mass number is given 23. Number of protons, you know that. That is 11. Now you can calculate the number of neutrons. N equals 23 minus 11. N equals 12. Right? If you know the mass number, if you know the atomic number, you can calculate the neutrons. Because the atomic number is equal to number of protons, and if the atom is neutral, that is equal to number of electrons. So if any atom is given, you should be able to calculate. Then electronic configuration. That is the maximum number of electrons that can be accommodated in a particular or in the respective energy level. Now, in any energy level, there is a maximum number of electrons. So, electronic configuration means how these electrons are filled in the respective energy levels from one that is nearest to the nucleus outwards. So, for example, now if you get sodium, sodium has 11 protons. That is the atomic number. Now that is equal to number of electrons. So number of electrons are also 11 because sodium atom is neutral. Then you should be able to indicate how these 11 electrons are distributed in these energy levels. First energy level, how many electrons, second, how many, third, how many. You know the maximum number of electrons that can be filled. 2, 8, like that. So, sodium, the first energy level, 2. Second, 8. 1 remaining, that is to the third level. It should be like 2, 8, 1, not 2, 9. Because 9 electrons are not possible for the second energy level. Now, you should be able to remember these 20 elements and their electron configurations you can write as you know the atomic number. You should be able to remember the atomic number of each in order. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Then if you are given the atomic number, you can write the atomic number in order. Then you should be able to write the electron configuration. For example, we'll get chlorine. Chlorine, it is 7. It is 17, sorry, chlorine. So, first energy level, there should be 2 electrons. Second, 8. That is now 2, 8. 7 electrons are remaining. That should be 2, 8, 7. Calcium, 20. It should be 2, 8, 8, 2. Like that, if the atomic number is given, you should know the number of electrons that is accommodated for each energy level. Now, the modern periodic table. You should know the properties, chemical properties, physical properties of these atoms. The patterns of the variation of their properties. So the modern periodic table helps it a lot. Now, as at present, there are more than 115 elements, and their properties cannot be individually considered or studied. There should be a pattern. And even it is difficult to memorize their properties individually. So it is easy if we can have a pattern or same type of elements are categorized periodically. So periodic table is the best way of classifying elements, and it was introduced by Dmitri Mendeleev. The modern periodic table is based on the atomic number. You know, atomic number is the number of protons in the nucleus, and it is equal to number of electrons. So the modern periodic table is based on the atomic number Z. So atomic number is the electron configuration, because you know the electron configuration is determined by the atomic number. The periodic law states that the properties of elements are periodic functions of the atomic number. You should know this periodic law. Periodic law states that the properties of elements are periodic functions of the atomic number. That means based on the atomic number, these atoms are positioned in the periodic table, because they have same properties based on the variation of the atomic number. Elements are arranged in the ascending order of the atomic number. You know the ascending order. The atomic number is arranged in the ascending order in the periodic table. And the elements with similar properties recur at regular intervals of elements. It means now when this periodic table has arranged in such a way that the same type of the elements with same properties recur at regular intervals. When you study the periodic table, you can clearly understand that. First of all, you should identify the groups and the periods. So these are groups. These are periods. For your level, actually for GCO level, only 1 to 20 elements are studied. Therefore, this detailed periodic table is not required. It is difficult to remember. But it's better that you can see the metals, non-metals, metalloids and noble gases. And you can see the groups and periods here, group 1, group 2, group 3, 4, 5, 6, 7, 8 or 0. And also the abbreviated or the part of the modern periodic table which is in your syllabus, which is very short. You have to remember. You have to remember the periods and the groups. So group 1, hydrogen, lithium, sodium, potassium. Group 2, beryllium, magnesium, calcium. Group 3, boron, aluminium. Group 4, carbon, silicon. Group 5, nitrogen, phosphorus. Group 6, oxygen, sulfur. Group 7, fluorine, chlorine. Group 8 or 0, helium, neon, argon. So these are the groups. In the period 1, hydrogen, helium. Period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine to neon. Period 3, sodium to argon. Period 4, potassium, calcium. So you should remember this, the part of this periodic table. So here they say, the horizontal rows are periods. The vertical columns are groups. Then the dividing elements into periods. So the period to which an element belongs is decided by the number of energy levels or the shells that carry electrons. Now period 1, the first row, hydrogen, helium, only first energy level has electrons. Period 2, there are 2 energy levels. It means 2 energy levels are occupied with electrons. Period 3, or the third row. Third row, you can see third row here. Sodium to argon. There should be 3 energy levels. Group 4, there should be, period 4, there should be 4 energy levels. So, based on the number of energy levels with electrons determines the period. Hydrogen, helium, period 1 or the first row. Lithium to neon, second row. Sodium to argon, third row. Potassium, calcium, fourth row. That is with the help of number of energy levels. Hydrogen, helium, 1 level. Lithium to neon, 2 levels are filled with electrons. Sodium to argon, 3 levels are filled. Potassium to calcium, 4 levels are filled. Then the elements should be grouped. How the columns are determined? That is determined by the electrons in the last shell or the last energy level. Number of electrons in the last energy level. That is known as the valence electrons. Valence electron means the number of electrons in the last energy level. If the valence electrons are 1, if the last energy level has 1 electron, that is group 1. If 2, group 2. 3 electrons, group 3. 4 electrons, group 4. 5 electrons, group 5. 6 electrons, group 6. 7 electrons, group 7. 8 electrons, group 8 or 0. Now, for example, hydrogen. Atomic number is 1, electron configuration 1, group 1. If you consider nitrogen, atomic number is 7, electron configuration 2, 5. What should be the group? 5, group 5. Why? Valence electrons are 5. If you consider magnesium, electron configuration is 282. The group should be 2. Why? The last energy level in magnesium they have 2 electrons. Therefore, group 2. Beryllium, group 2. Why? Last energy level has 2 electrons. Fluorine, group 7. Why? Last energy level for the valence electrons are 7. Last energy level has 7 electrons. That is how to determine the period and the group. Now, if you know the period and the group, you can find the position of any element in the periodic table. Now, if you consider magnesium, 282. 3 energy levels means the third row. 2 electrons in the last energy level means group 2. Third row, group 2. Third period, group 2. That is how to find the position. If you take potassium, it is 192881. So 4 energy levels are there, should be fourth row or the fourth period. Last energy level has 1 electron, so group 1. Now you know the position. Group 1, period 4. Very easy. Now, if you know the atomic number, if you know the electron configuration, you know the period of the element, you know the group of the element. These details are very, very important. Now we can stop recording.